Today we're going to look at part 3 of writing formulas and other chemical nomenclature. We're going to look at naming and writing formulas for acidic compounds and covalent compounds. Okay, to start off with, how is an acid formula going to be distinguished from ionic and covalent formulas? As we discussed in class, acid formulas are going to, for the most part, be identified by the formula starting with the element hydrogen. The names of acidic formulas are self-identifying because they actually have the word acid in them, so they won't be too difficult to identify. So we are still going to use our periodic table. Two things that you need to know about acids is hydrogen will have a +1 charge. The other ions that could be involved in an acid will have charges that we use in the same capacity that we used for ionic compounds. Generically, the formulas of both binary and ternary acids are listed on this slide. Okay, a binary acid has the general formula HZX, where X is a monoatomic or single element anion that has a charge of Z. The formula is generated by doing ion crisscross. A ternary acid has the generic formula HZ parentheses XO3 close parentheses 3, where XO3 is representing a polyatomic ion and Z represents the charge of the polyatomic ion. In general, most acidic formulas are going to start with H and be followed by either a single element ion or a polyatomic ion. The subscript that follows hydrogen will either be a 1, 2, or 3, depending upon the charge associated with the negative ion. Okay, there's no subscript following the negative ion because the charge of hydrogen ion is positive in an acid. Okay, so essentially formula writing is just like ion crisscross. You're going to look up the charge of the hydrogen ion, which is +1, and the charges of the anion and do the crisscross. So if you were looking at the formula writing for an acid, in cross-section here, you would have the hydrogen ion that's involved in the acid, and for the case of a binary acid, a single non-metal anion. Okay, depicted here, H has a +1 charge, and the single element anion has a -Y charge. If you crisscross the charges, then the formula would be HYA, where Y is the charge of the anion A. In the case of a ternary acid that contains a polyatomic ion, the crisscross would use hydrogen ion with a +1 charge and the polyatomic ion with whatever charge is associated with it, here depicted as Y. Okay, you would do ion crisscross, so the subscript on hydrogen would be Y. At this point, we're going to consider writing acid names from acid formulas. This generally is the part of formula writing that students have the most difficulty with because this requires learning a particular rule. Okay, so it is very important that you learn how to identify things that are binary. When you're naming a binary acid, like the example here given, HCl, the procedure would be to look up your nonmetal's name, attach a hydro prefix to the nonmetal name, and then attach the "ic" suffix to the nonmetal name, and then add the word acid. So since this is chlorine, we're going to take part of that name chlorine and attach the hydro prefix to it in the "ic" suffix. So the resulting formula is hydrochloric acid. The chlor coming from the chlorine, the "ic", the suffix, hydro, the prefix. So anytime you have a binary acid, it's hydro, some part of the metal element name, followed by the suffix "ic", and then the word acid. So take a moment and try the examples for binary acids. Okay, to name the names of ternary acids, you need to know that ternary acids depend upon the name of the polyatomic ion that they contain. Ternary acids are always comprised of hydrogen and some polyatomic ion. So we have two basic rules that we have to follow when naming ternary acids, and it depends upon what the name of the polyatomic ion is. If the polyatomic ion in your acid ends with the letters ITE as the suffix, then procedurally, to name the acid, you would change the ITE suffix to the suffix OUS and then add the word acid. So, to give you an example, take the acid formula H2 parentheses SeO3. This acid contains the polyatomic ion selenite. Selenite. So if I took the word selenite, I would drop the ITE and change the ITE to OUS. So the main word is selenous, and then I would add the word acid, resulting in the formula name selenous acid. H2SeO3 is known as selenous acid. Occasionally, you will have to drop some part or some portion of the polyatomic ion name so that it makes sense. Okay, I'm really not going to be too particularly picky with you about that. I just am going to be looking for the correct ending. After you become familiar with formula writing, you'll be able to predict, the small single vowel sounds that you might leave out in order to make a more appropriately sounding formula name. Okay. If your polyatomic ion does not end with the letters ITE, but rather with ATE, you're going to make the following change. You would change the ATE suffix to the suffix IC and then add the word acid. So the example given here is the formula H2 parentheses CO3 close parentheses. This particular acid contains the polyatomic ion carbonate. So our procedural way to name the acid would be to take the polyatomic ion named carbonate and drop the ATE ending. In the place of the ATE ending, we're going to place the IC suffix. So we change carbonate to carbonic, and then we add the word acid. So ultimately, the formula for carbonic acid is H2 parentheses CO3 close parentheses 3, carbonic acid. So you may remember, change ate to ick and ite to us and add the word acid. Okay, keep in mind that ternary acids never, ever, ever use the prefix hydro. That's exclusively for things that are binary. So take a minute to try a couple of ternary acid formulas. Now we're going to switch gears a little bit, and we're going to look at naming and writing formulas for covalent compounds. Okay, when naming a covalent compound from a formula, you need to pay attention to your periodic table to the covalent prefix chart. So I've placed a covalent prefix chart here, like the one that's on your periodic table. Okay, it shows different covalent prefixes that correspond to different numeric subscripts. And I specifically labeled it this way on your periodic table so that you would remember that a particular prefix dictates the subscript and vice versa. So I'm going to give you the example of the chemical formula P2O5. It's covalent because it does not contain any metals. So what I want to do first is I want to look at my chart and determine the prefix that corresponds to each subscript. So the subscript 2 is equivalent to the prefix di. The subscript 5 is equivalent to the prefix penta. So di is the 2, which represents the count of phosphorus. Penta is 5, which represents the count of oxygen. To name this formula, we're going to attach the first prefix, di, to the name of the first element, phosphorus. And then we're going to attach the prefix penta to the second element, oxygen. And then we will name the formula. To make it look like a binary formula, which this is an example of, we're going to end the second element name with an IDE suffix. So the resulting formula for P2O5, it will be called diphosphorus pentoxide. Now notice that I dropped the A vowel sound before I attached it to oxygen. Occasionally you might see somebody write pentaoxide. If you do, I would not count that wrong, but it flows better leaving out a preceding vowel sound.